Hi and welcome back. Well, let's do another version of using our graphs to make calculations. And this time, hi and welcome to another little video on helping you answer your questions. All right, we're going to look at a graph again and we're going to do some calculations. We're going to use a speed time graph. Now what I've got here in this times is all the times we have acceleration being at constant values because I've got straight lines, and I've chosen these ones to make it a bit easier for us. All right, again as the last time, whenever we see a change in direction of this graph, whenever we see a change in the graph, we know that's probably a good time for us to do calculations before that, and if we break it apart on those points, it makes our thinking a bit easier. Now I'll try to make it a bit easier for us in terms of numbers as we go through. So let's see how we go. This time we're looking at a speed time graph. Okay, so what we've got here is some good clear lines, and they show a constant change of speed. I know that because the lines are straight lines. And we've got a thing that goes all the way through from the starting point at 0 right through to 25 seconds. So what we've got to do is to think about breaking it apart. Remember I said the other day, or in the last video, about whenever we have a change in our motion and it shows up on the graph, that's when we should sort of think about stopping our calculation and starting a new one. All right, here is all right, this time I've used yellow, and we've got it up the top here. Now at the start, it was travelling at 0 metres per second at 0 time. So right at the start it was there. After 5 seconds, there's my change of motion, so I can see I'm going to stop at 5. After 5 seconds, it was travelling at 5 metres per second. So if I've got a speed and a time, then I know that the change of speed divided by the time it takes to do that is my acceleration. So I've got 5 is what my speed became. It started off at 0, and my time was 5 seconds, started off at 0. So we've got a change in speed of 5 over a time that took that to do that was 5. So we have 1 metre per second per second. Remember, per second, metres per second is speed. So whenever I'm doing it speed divided by time, it's another per second that comes into it. All right, there's the first one. There are 4 we've got to do here. That's number 1. Number 2, now we've got the flat line. And we know that the flat line means that we've got a constant speed. So if we've got a constant speed, we're not changing it. So our normal thinking would say it's 0, but let's prove it. Right, the speed at 5 seconds is 5 metres per second. The speed at 15 is 5 metres per second. So 5 minus 5. This time is 15 and the other time is 5. So I've got to change, oops, that's a bad math there, Mr. Carson. That should be 10 and something dividing 0, I think when my math is correct, it should be a 0. So we've got 0 metres per second becomes our acceleration. So in other words, we had no acceleration, so it didn't change speed. Speed remained the same, and our graph shows us that too. Continuing on, we go to the quick rise that is here between 15 and 20 seconds, and it says that at 15 we have 5. We start off at 5, but by the time we get to 20, it's at 20. So if we just plug these numbers in again, that's a speed at 20 seconds. All right, that's a speed at 15 seconds. That's the time, 20 seconds, and that's 15 seconds. So we have a change in speed of 15, a change in time of 5, so that means we have a acceleration of 3 metres per second per second. Right? Now remember back when we talked about distance times graph, we said that if we looked at distance time graph, the steeper it is, the faster it's going. Well, this is similar. The steeper our line is, the bigger our acceleration is. Let's do the last one. Let's finish it up. All right, this time we're coming backwards. Now we said acceleration is either speeding up or slowing down. So what we're looking at is the size of the difference. We only look at the size of the difference. We don't care. We're not sort of going to negatives and positives and things like that. It's all about the size of what we've got. So it says we've started off at 20 seconds with a speed of 20. At 25 seconds, we hit 2. And I read those off the graph. All right, so let's look at the change of speed. The change of speed is the difference between 20 and 2. So down here. And the change in time is the difference between 20 and 25. So we have a change in speed of 18 metres per second, a time of 5 seconds. So this tells me my acceleration is 3.6 metres per second. Now that means this line here is absolutely a little bit steeper than this line here because the numbers are bigger. I hope that helps, and I hope that makes problems easier in your test.